So starting with 5.3, this is part 1, solving polynomial functions. We have been working on factoring polynomial functions and writing polynomial functions from solutions, but we haven't actually solved them yet. So this whole section is going to be about solving those different types of polynomial functions that we are going to encounter as we go through this chapter. Remember that solving means to find the zeros, the x-intercepts, the roots, the solutions, all of those things of the function. So solving, again, if it says to solve, or find the zeros, or find the roots, find the x-intercepts, find the solutions, this is what we are doing. So for first example, what are the real or imaginary solutions of 2x cubed minus 5x squared equals 3x. So I have the steps listed for you to use when you go do your homework or do your practice. I want you to come back to these steps. So the first step is rewrite the equation equal to 0 if it's not already. We have to get the equation equal to 0 so that we can use the zero product property. So I'm going to move the 3x from the right-hand side of the equation to the left-hand side of the equation by subtracting it from each side. So now I have 2x cubed minus 5x squared minus 3x equals 0. Step 2, factor out the greatest common factor. GCF means greatest common factor. So what is it? Well, first of all, check your coefficients. 2, 5, and 3 have nothing in common, no factor in common that I can divide by. However, my variables do, or each term has a common variable. Each term has an x that I can factor out. So I can divide each of those terms by x. And when we are dividing by x, we are subtracting exponents, so to speak. So my 2x cubed becomes 2x squared when I divide by x. My 5x squared, or my negative 5x squared, becomes just negative 5x. And my negative 3x just becomes negative 3. That's the coefficient that would be left after dividing, equals 0. So at this point, I can go ahead and use my zero product property. I know that x times the quantity 2x squared minus 5x minus 3 equals 0. That means one of those two quantities has to be equal to 0. So either x equals 0 or 2x squared minus 5x minus 3 equals 0. So since I do have a cubic function, I should have 3 solutions. Well, I already have one of my solutions, x equals 0. So now let's use factoring to solve the quadratic part and find my other 2 solutions. I'm going to really quickly do this x method for factoring, and I will go into much more detail with steps on how to do it later in the notes. So let's go ahead and do this right now. So just really quickly, we're going to do a times c in this top part of my x. So 2 times negative 3 is negative 6. I'm going to put b in the bottom part of my x, which is negative 5. So I need factors of negative 6 that add to negative 5. So I know that negative 6 and positive 1 will work. So negative 6 times 1 takes me back to my top part of my x, negative 6, and then negative 6 plus 1 takes me to the bottom part of my x, which is negative 5. So now I've done that, I'm going to take my a term, which is 2, and I'm going to do negative 6 divided by 2, and that becomes negative 3 over 1. And I'm going to do this side over here as well. I'm going to do 1 divided by 2. And I'm going to quickly explain. I'll talk about it later. But this right here, my negative 3 over 1, my denominator is my coefficient of x. And my numerator is what goes in the parentheses. Same thing on this side, on the right side. My denominator is my coefficient of x. My numerator is a constant in the parentheses. So there I have factored. And all of this is equal to 0. So now I can again use my zero product property, and I can say x minus 3 equals 0, or 2x plus 1 equals 0. So I know that x equals 3. There's solution 2. And over here, I subtract 1 from both sides. divide both sides by 2, and I get x equals negative 1/2. And there's solution 2. So my 3 solutions would be this. X equals 0, negative 1/2, and 3. 3 solutions. That's what solving, when we do solve, we're going to take it all the way out. We're going to factor completely, set all of my factors equal to 0, and solve. Moving on to example 2. What are the real or imaginary solutions of 3x to the 4th plus 12x squared equals 6x cubed? So rewrite the equation equal to 0 first. So I'm going to have 3x to the 4th. I'm going to move my 6x cubed over. I'm going to put it in the middle because I want it to be in standard form. I need my exponents to be in descending order. So I'm going to subtract the 6x cubed from both sides and put it in between the 2 terms I had on the left. So 3x to the 4th minus 6x cubed plus 12x squared. So now we're going to factor out the GCF, and what is it? Well, I'm going to look at my coefficients first, and 3, 6, and 12 all have a coefficient of 3. They all can be divided evenly by 3, so I'm going to divide them all by 3. But they also have not just one x, they all have at least 2 x's that I can divide by. So I'm going to go ahead and factor out an x squared. So I'm going to divide everything up there, every term, by 3x squared. Well, 3 divided by 3 is 1, and x to the 4th divided by x squared leaves me with x squared. Negative 6 divided by 3 is negative 2, and then x cubed divided by x squared is just x. And then 12 divided by 3 is positive 4, and then x squared divided by x squared, well, that leaves me no x's at all in the parentheses. Okay, so again, I can now use my zero product property, and I'm going to go ahead and do, say, 3x squared equals 0. And I'll come back to that in a minute. And I'm going to say x squared minus 2x plus 4 also equals 0. So next step would be to factor the quadratic if possible. So I'm going to ask myself factors of 4 that add to 2. Well, I know 4 times 1 equals 4, but 4 plus 1 is 5. So that won't work. I mean, it does equal 5, but it doesn't equal 2. That won't work. And then 2 times 2 is 4, but 2 plus 2, does not equal 2. So I don't have any options to factor. So that will sometimes be the case. If you cannot factor, you can always use the quadratic formula. So just a refresher, quadratic formula is the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we're going to use the quadratic formula. First thing I'm going to do is I'm going to say a equals 1, b equals negative 2, and c equals 4. So using the quadratic formula, the opposite of b is positive 2 plus or minus, well, b squared, negative 2 times negative 2 is positive 4 minus 4 times a times c, all over 2 times a, which is 1, so all over 2, because 2 times 1 is 2. So I'm going to go ahead and simplify. 4 minus negative 4 times 1 times 4. Well, negative 4 times 1 is negative 4, and then negative 4 times 4 is negative 4. So this radical, I won't do that. I'm going to do that. Simplifies to 4 minus 16. And 4 minus 16 is negative 12. So under my radical, I have a negative 12. So over here, I'm going to simplify this. I'm going to show you that how we simplify the radicals. I'm going to take the square root of negative 1, and then there's a perfect square factor of 12, and then there's a 3. So I'm going to take the square root of negative 1 and the square root of 4 and simplify those out. So the square root of 4 is 2. The square root of negative 1 is I. And under the radical, I still have a square root of 3. So while we have already done quadratic formula, we're using it again. And we've done imaginary numbers, and we're using them again. There is the purpose that we learned those things first semester. So all over 2. Now I want you to pay attention to all of my coefficients. This one, this one, this one. They all have a common factor of 2. Since they all three have a common factor of 2, I can divide all 3 of them by 2. They have to all have that common factor, or I cannot simplify. So I'm going to divide all 3 of those by 2 and simplify my answer to 1 plus or minus 1i, or just i, square roots of 3. 2 divided by 2 in my denominator becomes 1. I don't need that in the denominator. Okay, so 2, I divided everything by 2. So I don't need that in the denominator. So here are 2 of my solutions. So 1 plus or minus I square roots of 3. This is 2 solutions because of that positive and negative. It's 1 plus I square root of 3 and 1 minus I square root of 3. 2 different solutions. Now let's come back up here and let's solve this one. So this quadratic formula, maybe. Okay, I'm going to erase this quadratic formula and I'm going to solve my 3x squared equals 0. Since all I have is an x squared, I can just do square roots. So I'm going to divide both sides by 3 and I get x squared equal to 0. I take the square root and I get x equal to 0. Now, we're supposed to have 4 solutions because I have a leading degree of 4. So what I want to point out, though, is since this was an x squared equals 0, that means 2 of my solutions are 0. So here would be how I would say this. I have x equals 0 with a multiplicity of 2. In other words, my 0 occurred twice. If it's just x equals 0, that's just 1 time. But since it's x squared equals 0, that means 2 of my solutions. I also have 1 plus or minus I square root of 3. I wrote multiplicity of 0. I'm so sorry. Multiplicity of 2. I'm so sorry. 0 is a solution with a multiplicity of 2. And then 2 of my other 2 solutions are 1 plus or minus I square root of 3. If you have questions, ask. Write them down. Ask why I went from where I went. So, moving on to example 3. What are the real or imaginary solutions of x to the 4th minus 3x squared equals 4? So again, we're going to rewrite the equation equal to 0 first. X to the 4th minus 3x squared minus 4 equals 0. All right, I want to point out that we have a 4 as an exponent and we have a 2 as an exponent. And I want to remind you, when we have a quadratic, say we had just x squared minus 3x minus 4, notice my exponent here is 2, my exponent here is 1. My exponent in the middle term is half of my exponent in the leading term. So in that case, I can factor that because I know my middle term is going to be that. Well, over here, my leading term is 4 and my middle term exponent is 2. My middle term exponent is half of my leading term exponent. So I can go ahead and take the square root. Basically, my middle term, the variable, is the square root of my leading term. So when I take the square root and put each of those into parentheses, notice it becomes x squared, which leads me to my middle term of x squared. So I can factor it just like a quadratic. That's an option we have when this works, if it factors. So I'm going to go ahead and now I'm going to do factors of 4, factors of negative 4 that have a difference of negative 3. Well, I know 4 times 1 is 4, and I know 4 minus 1 is 3, but I need it to be 1 minus 4 to get my negative 3. So negative 4 times 1 is negative 4, and 1 minus 4 is negative 3. So I've already put the negative 4 in the parentheses here. I already did that for you. So that means this side is just going to be x squared plus 1. So now I'm going to go ahead and use the zero product property, and I'm going to say x squared minus 4 equals 0, and x squared plus 1 equals 0. Now, since these are both just x squareds, I can just use square roots to solve. So I'm going to add 4 to both sides, and I'm going to get x squared equals 4, and I'm going to take the square root, and I'm going to say x equals positive or negative 4. two of my solutions, one plus, one minus. Not the same. There's no multiplicity here because one's positive 4, one's negative 4. On this side, I'm going to subtract 1 from both sides. And I'm going to get x squared equals negative 1. I'm going to take the square root. And I'm going to get x equals, well, the square root of negative 1, if you remember, is positive or negative I. Plus or minus I. So there are my 4 solutions. So I would actually list these as this. Here are my solutions. I would list that, not a comma, x equals 4, negative 4, I, negative I. Okay? So that's example 3. Kind of similar to factoring quadratics, I just end up with an x squared minus 4 in a parentheses and an x squared plus 1. So instead of just having one x in the parentheses, we have an x squared. Last example for this video. This is where we're going to do the x method in a little bit more detail. I believe this is a lot. Maybe we have one more example in this video. I'm not sure. Practice factoring when a doesn't equal 1. So we're going to use the x method. I don't have any common factors. 5, 8, and 69 don't have anything in common that I can factor out. So my first step is to identify my a, which is 5, my b, which is 8, and my c, which is negative 69. So you're going to multiply a and c, and I want you to just go ahead and drop down. Once we multiply a and c, drop down to this step. Okay, this tells you what we're doing with a and c. We're going to be looking for factors of this product that have a sum or difference, depending on your second sign. And we're not even going to really depend on our second sign. We're going to just go ahead and multiply my a and my c. So 5 times negative 69, well, 5 times negative 60 is negative 300. And 5 times negative 9 is negative 45. So I put negative 300 and negative 45 together to get negative 345. Mental math, that's a way to do it. I need factors of 345 that have a difference of 8 because it says put the product of a and c in the top box or the top of the x. We did, negative 345. Put b in the bottom of the x. I did. I put 8. On the left and right, I'm going to put my factors that will multiply to negative 345 but will add to 8. So I know it can't be very big numbers because they have to be 8 apart. And I know something like 5 would go into 345, but 5 goes into 345 69 times. I mean, that's just too far apart. That's a difference of 64. We need to have a difference of 8 between them. So since my number ends in 5, I'm going to try 15. So when I divide 345 by 15, I get 23. And 15 and 23 do have a difference of 8. Okay, I need my 8 to be positive, so I need my 15 to be negative, and my larger number needs to be positive, and my smaller number needs to be negative. So now, just to check, negative 15 times 23 takes me back to negative 345, and then negative 15 plus 23 takes me to positive 8. So there's kind of what we're doing with the x method. Just want to point that out. And my next step that you see. So we've taken the two factors and we put them on the sides. Doesn't matter which side is which. So now I know my factors. My next step right here, divide both factors by a. So I'm going to put negative 15 over 5, and I'm going to simplify that to negative 3 over 1. And I'm going to put 23 over 5, which is a. And that doesn't simplify, but I'm going to leave it. Do not divide it out. You just have to simplify it. So here is what's in my parentheses right here. Okay, the denominator is your coefficient of x. So my first parentheses, my denominator here is a 1, so that's my coefficient of x. And then I do my numerator is negative 3. So the numerator is the constant in each parentheses. I forgot an S right here. So, sorry. Second parentheses, my denominator is my coefficient of x. My numerator is the constant in the parentheses. So I have now factored that. Now we can solve. It doesn't say to solve, but to solve, I just set it equal to 0. And I say x minus 3 equals 0, or 5x plus 23 equals 0. Okay, so I know that x equals 3. And over here, I know that 5x equals negative 23. So x equals negative 23 divided by 5. So there are my two solutions, 3 and negative 23/5. And I should have two solutions because my leading exponent, my leading degree is a 2.